Good day all, myself Chandra. So in this session, we will discuss about parallel for each scope and how we can implement the parallel for each scope using an example. So basically, parallel for each will accept an collection or elements and it is going to split that collection into individual messages and the messages will be processed in parallel or we can even mention it as a simultaneous process. And the message processors that are configured within the Foreach scope are going to be executed for each element or for each individual messages. And the message processors will be executed in sequential manner for each individual message. But the messages that are split into individual messages will be processed in parallel. So the result of the one message is not dependent on the other message. And we cannot reuse the result of one message in other message. So by default, it will be iterates or payload. So if we do not provide any configuration for the collection, then it will defaultly consider the payload and split the messages or split the collection. And if we want to change that payload collection, then we can configure by using a expression. And also the result of the parallel for each scope will produce an aggregated payload or aggregated result. And the payload will be modified after the execution of for each scope process or after the completion of for each scope. And we cannot set the batch size or there won't be any counter variable. Or no root message. Because the messages are processing in parallel, we cannot use this counter and root message. But we can set the timeout for the messages that are going to be processed for throughout the for each scope. So if we want to set a message timeout limit, then we can set it. And we can even mention the level of parallelism by using max concurrency property. It means so the parallel for each scope is executing threads in parallel or simultaneously. So to define any maximum parallelism, for example, if we want to define only 3 or 4 threads to be run in parallel, then we can define that kind of parallelism by using max concurrency property. So we will define that using a Anypoint Studio. In our suppliers API, scopes implementation, define a new flow. Add HTTP listener. Mention the resource name as P4H. I'm going to add a transfer message. And this transfer message, I'm going to set the values 1 to 10 numbers. So array of 1 to 10 numbers. And I am going to add a logger. I'm adding 2 loggers so that we want to know the payload before for each scope and after for each scope. Before for each. And add a parallel for each scope. So this parallel for each scope will have different property. So we have a collection. If we do not mention this collection, it is going to split the messages based on the input payload. And we can mention the timeout to be defined if we have configured 4 message processors within parallel for each scope. And if it is not completing that process for the individual message within that particular time, then that message will be failed. and we can set the max concurrency. And also this target and target value. Basically, we have said that the payload will be modified after the parallel for each process. That means we are producing a list or array of 1 to 10 numbers. So after the execution of parallel for each, the payload will not be the same as 1 to 10 array. And we have one more property like target and target value. So this target value is going to be assigned to the payload by default. So the payload of this parallel for each result will be assigned to a target payload since we are not defining any target property. If we are going to define any target property with this name, for example, if we are defining result, so a target with variable name result will be created and the value for that result variable will be the payload of this parallel for each scope execution. That means it is going to produce an aggregated result into a variable result. Right now I am going to remove this target and we do not have any collection, timeout, max concurrency and target properties configured. So the result after the parallel for each will be changed. So we will observe that. Now we are going to configure two more loggers. Payload in for each, P for each, start. And payload P for each n. So in between this, I want to increment the value. Use the transform message. Basically, it is not only the transform message or a simple operation. In real use cases, to process multiple things, we are going to use parallel for each and we will call many components, or if there is a need, we can even call the other APIs and we can call other subflows. So like that, we are going to make use of parallel for each. So it is going to execute the process faster because it is running the threads in parallel. So now we want to increment the value with 5. Define a variable increment 5. So instead of adding the value here, add the value increment. And we need to understand that whatever the variables that we are going to define within the transform message are limited to this particular component only. In general, whenever we define the set variable components within the flow, those variables are accessible and it can be used within the flow after the declaration of the variable. But the variables that are defined within the transform message are limited to it. So I'm going to create variable also. In generally, whenever we create the variables outside the parallel for each are accessible within the parallel for each or after the parallel for each scope. But if we define any variables within the parallel for each, those are limited to this particular scope. So I'm going to create a variable 1 and value new variable in P for each. So for each of the individual message, the value will be same. And I'm adding the payload here so that we know we are going to concatenate the value new variable in P for each and the payload. So that means every time it is going to add 1, 2, 3 like that, the messages. And here we have a payload. Add one transform message at end of the flow to define the result. I am going to declare a payload here. JSON, save the changes. Application is deployed. Test from Postman. So resource name is P4H. Send a request. Observe the logs. So we have a payload before Foreach scope, and it is the array of numbers 1 to 10. And after that, the payload in P4H are executed. So all the components are executing in parallel. To understand that, we can see that the start logger has been executed in parallel and it is printed in the console. What will happen in for each scope, the messages are going to be executed in sequential, so that you can observe that for each message, the logger will be started and then the logger will be end. After that, the second message is going to be picked up and processed. And that way, the messages, individual messages are going to be processed one after the other in for each scope. But in parallel for each scope, the messages will be processed in simultaneous way or in parallel. And here we can see that payload after for each scope. Yeah, and here we can see that payload in for each n. Here we have the value of 11, 10, 8, 7. So that it is like whatever the execution of the message is completed first, it is going to produce the result. So it is not going to wait for the result of other message or other individual event. And here we can see that the payload after for each scope is different from the input. So in input, we have a 1 to 10 numbers. And then in output, we have a messages with inbound attachments, payload, and attributes. So which is a message like aggregated or collection of individual messages, and it will also contain other properties like exception payloads, attributes, and other information as well. So likewise, the result of the scope will produce an aggregated payload or result. So to access the payload within the process, we need to configure a different expression. So here we can configure that. We need input values. So input values are in. So we need input values. So for that, we are going to add input request. So we will define an input request variable, and then here output values. So output values are within the payload. So payload is a collection, and within that collection, we have the payload field. So we are going to access the payload, and then we will try to verify the variables that are available throughout the flow. I'm going to define one variable. It is payload input request. Once the application is deployed, test from Postman again. So instead of having these individual collections, And we need to observe that whatever the payload that we have sent to the Foreach scope, it is going to aggregate the result in the same sequence. For example, we have sent an input request 1 to 10. So the result is also going to produce in the same order the aggregated result, like 1 plus 5 will become 6, and then 2 plus 5 will become 7. And also the last message we have a 10, and 10 plus 5 will become 15. So likewise, it is going to aggregate the result in the same sequence. We will send a new request for the flow. And if we observe, we have input values and output values and the variables. So variables are available only that are defined before the for each scope. And you cannot see the variables that are defined within the for each scope. So we need to understand that the payload will be modified after the parallel for each scope, and also the variables that are declared or defined within the parallel for each scope are not accessible outside the parallel for each scope. But you can access the variables that are defined before the parallel for each scope within parallel for each scope. For example, I mean to say here you can access a variable that was defined before the parallel for each scope. We have defined a variable input request, so you can see that variable here. And now we have a result, we have an output value. But if you want to calculate the sum of these input values, you can do it in different way in parallel for each. So you cannot perform the sum by using a parallel for each, because it is not dependent on the previous messages. So in parallel for each, we cannot perform the operation to calculate some of these numbers, because the messages that are going to be processed individually and parallelly. So we cannot have some of the first message with second message. So it is going to be independent. To calculate some of the numbers, we can use a different operation. But this parallel for each is going to be useful if you want to perform any operation that is independent of each message, and it is going to produce a faster result compared with for each scope. So here you can have a value where start input request, and you can perform a sum of this. So to produce a result with sum, input values sum. But to calculate the output value sum, you can still increment the values within the parallel for each scope, and you can use that values, aggregated values, and you can perform a sum operation here. So on output value sum, you can perform the value. So you are incrementing each message and then performing a sum outside the parallel for each scope. Save the changes and we will test one more time. Send the request. So here we have input values, output values, and we have input values sum and also output values sum. So in this way, we can perform an operation that can be used to increment or perform any operation on the individual message, and also you can aggregate the result after the for each scope. Now we are going to configure another property, max concurrency. So I'm going to define max concurrency as 4, and we will see the result, how it is going to behave. Application is deployed. Send the request. The result or response, there will be no change, but the execution of the events will be changed whenever we have configured the max concurrency property. Here we can see that earlier we have parallel for each start loggers 10 times in the sequence. But if we see now, we have only 4 message loggers that are started. That means for each 4 messages, it is going to consider and create threads, and then it is going to process the records. And once that process is completed, then it is going to pick up another 4 records or 4 messages, and then it will process. Likewise, it is going to split the messages and create a parallelism, a number of threads that can be performed for the parallel for a scope, and it is going to process the execution. Since there are 10 messages, so initially it has executed 4 messages, and then in the next iteration, it has executed another 4 messages. So there are 2 messages remaining, and those remaining messages will be executed in the last, and it is going to execute those 2 messages in parallel again. So this is about max concurrency. And we can even configure the collection. For example, if you want payload dot any collection name or key name that you wanted to perform the operation, then you can mention number values. Likewise, if you have number values that is defined, then you can perform that operation. So this number values is going to hold the 1 to 10 numbers. Then you can provide that configuration or expression into the collection. I am going to remove this. If you want, you can try. And we will see one more, and we are going to raise an exception and observe the result. So I want to raise an exception whenever there is a record number or the value is 6. So I want to check that payload equal to 6 or payload equal to 8. So I want to check this condition. If payload equal to 6 or 8, then I want to raise error. Type parallel for each error. So this is our message. And I'm going to configure error handling here. On error, propagate, and add a logger. Here, add a error. Save the changes. Run in debug mode. Application is deployed. Let us send a request. We have added a debugger breakpoint before the parallel for each scope. Proceed further. And we have 1 here. So for each 4 messages, it is going to process, and still we are having that configuration max concurrency. Yeah, let us move further. And I'm going to verify here at a breakpoint and then proceed. 8. So payload is 8 and it is going to throw an exception. So expression for each, let us see the result. And whenever we are executing this parallel for each, even though there is an error in the individual message, in any of the message process within the parallel for each, the process will be continued. And then once all the messages are completed, then it is going to throw error with the collection of result or aggregated result, and the error will be handled. Now, all the messages are completed with the parallel for each process. And let us observe this. We have parallel for each. And here it is throwing an exception, mule composite routing exception. Whenever there is a failure in any of the message within the message process of parallel for each, then it is going to throw an exception, mule composite routing. And this mule composite routing, we can observe the result. So we have mule message. So within this mule message, we can have the different values. So let us check this. Error dot mule message. It is having routing result. Mule message dot failures. Let us check. It is having a routing result type. So to convert this, add a expression DW 2.0 and then output JSON. And now we can observe the values. To pin this, I mean, even though we are moving out of this Anypoint Studio, if you want to pin this debug expression, then you can use this here on the dropdown, select pin. And we will observe this. There is a failures, supplied errors, error type. I'm going to copy this and then paste in the notepad. We will observe this. There is a failure and this 5 will represent the message number 5. And it is having some error. Identifier is error 1, P for each namespace. And also we can observe what is the issue. Expression error in P for each. So we are raising a custom message and we can observe that error. Likewise, there will be a different exception, or if there is any result, then we can see that result in the results. So within this error dot error message, we will have 2 different sections. So let us note that if any exception happens, then the messages will execute the process without stopping the execution because of failure message. Once all the individual messages are processed, then P for each will raise below error and it will have result and failures in error message payload section. So if you want to know what are the failures or what is the results, then you can accept by using error.error-message.payload. And if you want to know which message has failed, you can check that by using the index number. For example, if there are 10 messages, so each message will be having an index 1 to 10. If there are 20 messages in the if there are 20 messages after splitting the collection, so within the Foreach scope, so then there will be a 20 indexes for the results and failures if there is if there is an exception. And same is applicable whenever there are no exceptions. If there are no exceptions, you can accept the result by using payload.payload of 0 or 1, like, so this will be our index. Now we will see this. I'm going to remove this pin. And instead of the logger, we will add transform message and observe the result. So data view, I'm within data view, I'm going to mention JSON. Here we want to check error message dot payload, and within payload we want to know the errors and also the results. Yeah, here instead of on error propagate, add on error continue, because we want to return this result instead of throwing an error. Save the changes now and we will send a request. We can see that fifth record has failed and it is having an exception error in, and it is having an exception expression error in for each. And we will observe the other record. Seventh record is also having an exception. So by using these failures, you can come to know which are the messages are failed. And within the results, you can have the successful results of the processors or of the messages. So here we will come to know which are the successful messages and what are the outputs. And we will configure one more scenario. So instead of assigning the value to payload, let us assign the value to a variable here, p parallel result. So this result, we are going to use it instead of the payload. Since we are going to assign the parallel for its scope result, or payload value to a target name. So this payload value is going to be assigned into the p-result variable. Now, to access the result of the parallel for each, instead of using the payload, we need to use vars.p-result, and then you can access the payload. Here also we need to mention that save the changes. And we are going to remove this choice condition since we want to produce a successful result. So like we have done in for each scope, if we still wanted to continue, if there is an expression in any of the message processors within the parallel for each scope, then also we can perform the until successful scope configuration or try scope configuration even in parallel for each as well. So this is all dependent on the requirements. I'm going to send a request. And if we see here, there are input values and output values, and also the result has been produced for the input value sum and output value sum. Because now we are accessing the parallel for each result using a variable p result. This way we can configure parallel for each. So the differences are like in parallel for each, we can have max concurrency property, and also we are not able to access the variables that are defined within the parallel for each scope outside the parallel for each scope. And we need to define a target name or target variable name if we want to assign the result of this parallel for each scope to a variable. And one more thing, the payload value will be modified after the parallel for each scope if we have not defined any value in the target property. If we are going to define any value in the target property, then the payload will be same as it was before the parallel for each. So here we are going to say input payload, and I'm still going to use a payload, and we will observe this. And till that time, we will discuss the differences, and we can mention the timeout property. And it is going, collection is same like for each. It is going to accept the payload, and it is going to split the payload into individual messages like it will be done in for each scope. But there won't be any root message or counter variable because this process is going to execute in simultaneous or parallel. This property is used to define the parallelism. And in for each scope, we have this counter variable, and also the scope and the message process within the for each will be executed in sequential manner for each message. So the second message is executed only after the completion of first message. Likewise, each message is dependent on the previous message. So if there is any exception while processing the messages, the execution of the process will be stopped and it will throw an exception. But in case of parallel for each, if there is any exceptions within the message process of parallel for each, it is going to continue the process for all the messages, and then finally it will throw an Mulesoft composite routing error, and it is going to throw the result in error format, and also the failures will be listed. And we have observed that how until successful scope can be used, and also try scope can be used. In same manner, we can implement that in parallel for each also. Let us test this. Because from the parallel for each scope, we are assigning the payload value to a variable p result. That is the reason we are still able to access the payload, and we are getting the same values that was there before parallel for each scope. This is the reason. If we are going to remove this target variable, then we are not able to access the same payload that was available before the parallel for each scope. And here also we have to modify, instead of batch.p result, we need to access that parallel for each scope result using a payload. So within the payload, there will be an aggregation of components and the each individual messages results. So you can access by using payload.payload. This is about parallel for each. And we are going to discuss about one more scope, that is cache scope. So basically in cache scope, we are going to store the result which is not modified very frequently, and instead of going to the target system or the third-party services, we are going to return the response from the stored results within the Mulesoft. For this purpose, we can configure the cache scope. So let us define that from Mule palette, configure flow. Within flow, add HTTP listener, and in HTTP listener, add a resource as cache, add a logger, cache scope started, and then we are going to refer a subflow using flow reference component. Within this, use the items data. So I want items information, items system B flow. Add a component, cache component, and within this cache component, add one more logger. Inside cache. Save the changes and we will test this resource. As of now, we have not configured anything, but we are using the default caching strategy. I'm going to use this within the cache scope. Deploy the changes and we will test the component and we will test the service. I'm going to send a request and we will observe the result. So we can see that cache scope started and then there is a logger inside cache. So we are getting the response and the cache scope is executed now. Let us send one more request. Whenever we are sending a new request again, then instead of getting the response from the subflow, we can see that response is returning, which is stored within this cache scope. And we can observe that from the logs. So the logger inside the cache scope is not executed. To understand this, we can check the configuration. So instead of using the default caching strategy, add a reference to the strategy and add a configuration here. So instead of using a default expression, add an expression. So instead of storing all the data directly into the cache, we can provide an expression like we want to mention that whenever there is a headers. So if there is a header with a source system, based on source system, we can store the response. And then if the same request is going to be provided again with the same source system, then we are going to request the response from cache instead of going and executing the subflow. So within this flow also, we can configure the logger so that we can easily understand. Add logger. Completed. Save all the changes. So this cache is stored only for temporary purpose. So whenever we restart the application, the cache will be restored. That means cache data will be cleared and it will wait for a new cache information. Let us send a request. Oh, okay, we need to wait. Send a request. Okay, now cache scope is started, but while storing the data into the cache, it is asking for a key generation error because it was not able to find the information that was defined in the headers. So here send a value, header value is source value. We want to mention it as system name. I'm going to mention HPT. Let us send a request. So whenever we are sending an information with the same source name, then instead of executing the subflow, it is returning the response from the cache. Let us try to add a different source system. And we will observe the result. Now, there is a cache scope started logger and within the inside cache, and also we can observe that subflow is completed. So whenever we are sending a new source system information, then we are receiving that information from the subflow. Let us try to send one more request with the same source. Now, if you observe that, it is returning the response from the cache instead of executing the subflow. Let us change this information. So instead of Tata, I want to mention other name, human. Let us check this. And now we can observe that subflow loggers and inside cache loggers are executed. For example, you might be having a doubt. In our previous request, we have sent an Tata as a source information. If there is a new request with a different source system or source header, is it going to override that cache data or will there be existing data as well? So we can check that by submitting a new request, but with the previously provided source information. Send a request and we can observe that it is still able to hold or store that particular information which was already served. Means that particular request was already stored and it is able to identify that particular information and it is returning the response from cache. We will observe one more scenario here. For example, if we want to cache the data only whenever that particular condition is not matched, and you mean to say that you want the fresh data whenever you receive a particular source information. So you want to execute the subflow, whatever may comes, whenever the source system is so and so. So you can use a filter condition here. Here I'm going to add a condition attribute star header and source. So whenever there is a HPT, I want to get a fresh information from the subflow instead of getting the information from the cached response. So I need to provide the condition like if source is not equal to HPT, then only store that information. Let us check this. Send a request. We have data and the request is served from the subflow. Clear the log. Send one more request. And now we can see that only the first logger is executed. Subflow loggers are not executed. Send a request with HPT as the source information. And the information is retrieved from the subflow. Clear the log. Send one more request. So whenever we are sending the request with the same source information, like whenever we are sending the information for the source HPT, we are going to fetch the information from the subflow instead of retrieving the cached data. So in this way, you can configure the caching strategy and the filter conditions. This is about cache scope. Now we have one scenario that was given in our previous session, like we have asked to increase the supplier side debit limit for each supplier side whenever there is a postal code starts with 5, set so and so limit, and if it is different from this postal code, then set a limit to a different value, 80,000. And we are going to see that particular use case. So in this use case, we need to observe that this information was not dependent on any of the message. For example, if we see there are 3 sites. So each site we need to provide a limit differently irrespective of the previous site result. So instead of using Foreach, for this use case, we can use parallel Foreach. But we can still able to achieve this by using both Foreach as well as parallel Foreach. So I'm going to use the flow. Add HTTP listener. For each sites. Add a logger. Input payload. And also here we are going to use for each scope. And this for each scope, we need to mention a collection because our structure is having a record of information, object information. Within this object, we have sites key. So we have to mention the sites, payload.sites as a collection. So it is going to split the messages or split the elements based on the payload.sites information. And then it will divide that messages, each individual record, and then it is going to process the message. Now add a logger. Add a transform message inside for each as well as outside the for each. For each start payload and add a payload. Here for each end payload. And within this transformation, we need to call a service. So that service is going to accept the postal code information, and based on that postal code information, we are going to get the limit. For that, I am going to define a subflow. Subflow. This subflow, I'm going to add a transform message, or let me do one thing. I'm going to add a simple choice condition and check the values. So our condition is like whenever the value, so payload starts file, then I want to set a variable. So this variable value is debit limit. I am going to set the value to 100,000. Okay. If you want this information in a particular format, then we have to mention that particular format. We will observe that. So add DW 2.0 and then output as JSON. And this information, if we want to produce in a digits also, then you need to use a as string and we have to mention format. So this format is like dot 00 or hash hash. So we will observe the difference in both cases. I am going to use same variable because we need to define the same variable name, but the value will be different. So instead of 100,000, we need to define 80,000 here. So here I'm going to use after the decimals, we want zeros here. And within this Foreach scope, we are going to call the subflow. Add a subflow. It is going to accept an payload, which is the value of postal code. So instead of sending the whole payload, we need to set a payload with the value of postal code and send that information to this subflow. So we need to use this payload here and mention that payload dot postal code. But observe that we need the main payload also. That means this each individual record payload as well. For that purpose, we can store the information in variable. So site payload. I'm going to store the information in site payload. Let me mention it. Site input payload. So within this site input payload, I want to store the actual payload that is going to be processed within this for each message. Add that information as JSON. And here we are going to mention the flow name. Here I'm going to name this as scopes debit limit subflow. Scopes debit limit subflow. So what we are going to do, we are going to add a logger for the individual payload, and then we are assigning the postal code to a payload, and actual payload, we are assigning the information to a site input payload record or variable. And then we are going to call the debit limit service or flow. In general scenario, it might be another API or it might be any connectivity to the external systems. It is all dependent on the requirement. And then what we need to perform, we need to set the new payload information with the record. So we are going to add one more transform message. Let me stop the process. Here within this transform message, add this as JSON. And we have an information within the variable vats.site input payload. So within this site input payload, we need to add new variable information. So that information we are going to assign it to the key debit limit, and information is available from the flow reference. So the flow reference, since we are not assigning the flow reference result to any target property, it is going to write the information into the payload. So here we are assigning the payload. So we are going to concatenate a input payload object to the new key debit limit, and then we are going to produce the result. So each individual message will be live. It is going to process this message each time, and then this postal information code is going to be set to a payload, and this information we are going to send this to debit limit service. So in our case, it is subflow. And then result or response of the debit limit service will be assigned to payload. And then we are going to concatenate these objects. Concatenate site input payload or record and new key value debit limit and the debit limit response. So our response for each individual record is like $100,000. But this is going to be like whether it is a 100,000.00 or it is going to be only 100,000, that we will check based on the expressions that we have configured within this subflow. We have provided a format expression, right? Based on that, it will assign the values. And also we need to, if we want to separate these values by 2 digits or 3 digits, then you can apply this format expression. We will observe this. So we have each individual record information here and form a new output. We have to use a variable, add a variable or within the transform message, or you can use directly variable. So here I'm going to provide a variable information and site result. So within this site result, I want this information as a list of array of records because the site's information is array of records. So we want the results also as array of individual objects. So I want vars dot site result and the default value should be array, and I'm going to combine the results of payload for each individual record. So that was assigned in previous step. So this payload I want to convert into a array because we are going to generate a final output as array. We need to convert this into a array of object. So I'm going to add a logger after each component. Here I'm going to mention site input payload, site input payload, transformed payload. Add one more logger because I want to know the result of this subflow. Payload. See the changes and deploy the application. Yeah, well, we forgot to do one more change. On the final transform message, add the expression. So here we want input payload, input payload. So input payload is payload itself, and then output payload. So in our output payload, we want the result. So the result is captured in site result. Application is deployed, send and request. So here we need to send a input body as well, raw JSON record, and instead of cache, for each sites, and copy this input payload. Send a request, and we are getting a response. So this is our input payload, and our output payload is having the information with each supplier site record and with the debit limit. And if we observe that, we have a postal code information, and also the debit limit is also assigned to a postal code value. So which is a wrong one. Let us see what was wrong in our flow. So we have transfer message and we are assigning the postal code. Fine. Let us go to this subflow. So within this subflow, we are mentioning that if whenever the value starts with 5, set a variable value with the debit limit and the value is with 100,000. That's fine. And here we have not defined any target variable. Okay, let us see this scopes debit limit subflow payload. Yeah, if we see here, scopes debit limit subflow payload value is coming as postal code only, which was sent as an input. But we have assigned a value to the variable. So instead of assigning and accessing the value as a variable, we are accessing the payload from the subflow response. So we need to access the variable here, vars.debit limit. Same is applied in the transfer message also. Observe that because within this subflow, we are not assigning the result to. So whenever any processor is defined within this subflow without a set payload or transfer message for payload component, then the result will be not modified. Whatever the input information that is going to be sent to this subflow will be come as a response. That's why we don't see a difference. Now we have assigned the debit limit. For example, in this subflow, instead of assigning the value to a variable, if we have defined set payload component and assign this value or expression, then there won't be an issue. It is deploy the changes and verify the request. Send a request again. And now we will verify the result. So in our output payload result, here we can see that the debit limit value is coming as 100,000 with a comma separated value after every 3 digits. Because we have mentioned an format of the expression to be separated by 3 digits. And even though we have mentioned that to have a decimal points, it is not appeared in this 100,000 format expression. And we can see that 2 digits with the zeros in the 80,000. So let us observe the difference for these two expressions. So whenever we define the value by using dash dash, so whenever we define the value after the decimal by using the hashtag, then it will not produce the result with the zeros if there are any zeros decimal, if there are any zeros after the decimal. But if we want the information in decimals, even though there are zeros, we need to specify that in the format of .00. Thus, I'm going to change the expression in both scenarios. So here also I will provide the zeros after the decimal. So now we have a same format, which will be divided with comma separated after every 3 digits, and also there will be 2 decimals after the decimal point. Send a request. And now we can see the result in the same format and also with the same decimals. In this way, we can achieve the incremental value for each message or each individual record by using the Foreach. And we see that this site information is anywhere relevant or dependent on the other site information. So instead of using this for each process, we can implement this process in a more faster and better way by using parallel for each. But if there are too many records or huge payloads that needs to be processed, the parallel for each is going to produce a out of memory issue. So instead of that, you can even implement that process using a batch. So there is a Mulesoft batch process as well to process large payloads and large chunks of data. And we see the examples in our coming sessions. So we have this information and we have a subflow. Let us implement the same mechanism using the parallel for each. So I'm going to XML and I'm going to copy this flow. XML, copy this flow, generate a new document IDs, and then name this flow P-scopes implementation, and then change the resource name. Instead of for each sets, add it as P for each sets. And I'm going to XML. So here, instead of for each, I'm going to add parallel for each. So at end of the tag also add the parallel for each. So change the name to parallel for each. And here we can see that the collection is same. We are going to iterate over the payload.sites information, and we are not defining any max concurrency, and also we are not defining the target variable. So what is needed, right? Here we have site information. So after this site information, we don't need to collect or aggregate this result, because in our for each scope, we are not able to aggregate the payload that is happening within the for each. We need to aggregate it manually, and in parallel for each, it is not needed. So remove that variable. And then here, instead of the variable site results, we need to configure a payload dot payload, and we have to configure one more variable before the parallel for each scope. So add a input request, and within this input request, store the payload information. That's the input request. And let us see, we have postal code information. We are going to send to the scopes debit limit flow. And also we have this information. And I'm going to save the changes and observe the result using parallel for each. Let us send same information to parallel for each also, and observe the result. So we have input payload and also the output payload with same set of results. Whenever the postal code is starting with 5, we have information with the debit limit 100,000. And if it is other than 5, then we are going to set the information to 80,000. So likewise, we can set the information by using parallel for each, as well as by using for each scopes. Now, let us try to understand one more scenario. Here we are calling this subflow, right? So instead of calling this subflow by using flow reference component, we are going to make a call from the data view using a lookup. And I'm going to remove this. So within this parallel for each, we have information. And to call the flow from the data view, we need to configure that as a private flow. So go to XML, and the scopes information flow, I'm going to set as private flow. So there is no source, but still we are having the message process, and it will have error handling. If any exception occurs, we can handle it within this private flow itself. So this is our information. So use a lookup function, and from the lookup function, call that subflow. So in our lookup function, we are passing a private flow name, and then after that, we are setting the payload, what information needs to be sent to the particular flow. and then we can define the output timeout as well. So in this way, we can call private flow from the data week component. Save the changes, and here make a change. So we are going to get that information into the payload. So here add a payload. So here instead of debit limit, add a keyword payload. We can do it many ways. So we are just observing the ways of defining and implementing the flows and data view components and also the scopes. Let us send a request. So the result should not be intacted. And now we can see that there is an issue, like it was having a scopes limit has failed with the mule expressions and payload 5001 as string, but it is expecting arguments of types string. Okay, instead of sending this value object information, you can directly send the string information. So here we don't need to set anything. Send a new request. And whenever we are sending a new request, now we can see that debit limit and postal code are coming as same. Yes, debit limit, and there is a variable. Since we are having the information within the variable, whenever we call this flow from the data view, it is trying to accept the value of payload only, and it is not able to derive the value from the variable. So we need to make sure that we have to provide that information. So set these variables instead of variable, set a payload here. Now remove these variables, save the changes and retest it. Send a request and observe the result. And now we can see that we are getting the correct debit limit whenever the postal code is starting with 5. And if it is starting with 4, we are getting 80,000 as a limit with a correct format as well. So in this way, we can achieve the results. If you like the video, please like, share, and subscribe, and you will be getting more interesting videos, and also we will have more scenario based topics in our further coming session. Thank you.